Hi Will, so we're going to talk today about cloud computing. It's a really exciting new area for environmental science. Can you firstly, I guess, tell us what it is, what it's all about?
Yeah, hi Richard. So cloud computing, I guess most people will have heard of things like Dropbox or Google Drive and Photos and backing up their data to the cloud. And that's one of the services that's kind of leverage cloud computing to great success. But what cloud computing actually is basically renting someone else's computer. So it was the public cloud, what we call the public cloud, was popularized by Amazon, I think, a few years back, when they decided that they would share their computing platform that they were building for their online shop and rent it out to people, whoever would pay, to run their businesses on their machines. And so they allow you to basically rent capacity in the cloud, and that capacity could be data, it could be a computer in the cloud, or it could be a whole series of computers in the cloud, and only pay for what you use when you use it. So if you have a website or something that processes your online shop order, you might rent capacity in the cloud. Equally, if you're an environmental scientist, you might rent a computer in the cloud to analyze your data, run models, store your data, and share. And it allows you to basically share your data or your output with anybody with a computer connected to the internet. So it allows you to really add resource to your scientific computing, and pay just for what you've used, and add extra resource just when you need it.
I guess at the moment, really, as kind of environmental scientists, or indeed any kind of science discipline, we've got we work at universities, we have our own high performance computing. These are kind of really high spec servers, in a sense, with lots of CPUs that allow us to run really complicated models. I guess cloud computing, how will this fit? How, I guess, will the model change? Or we still use our HPCs? Will we just use cloud computing, kind of a hybrid of the both?
So you might different use cases might suit different infrastructures, as it were. So your university high performance computer is very expensive, has to be running constantly to pay for itself, as it were. You can't just leave it idle. So you end up with having to kind of schedule the jobs. People might lodge a request to run a model or analyze some data, and then they'll be given a time slot for that to run. Whereas if you in cloud computing, you can instantly pay the spot price for the resource that you need and have that run. And so it might suit different ways of working. The university HPC, it will be in the university network, and your data will be there, so you'll have to go through another layer of complexity to be able to share that data, to share that analysis. Not everyone in the street has access to a university HPC, so there might be other organizations interested in running the code you've developed as an environmental modeler that maybe don't have access to a university HPC. So you might want to put that in the cloud to share it out, to kind of democratize it in a way, and allow other people to access it from all kinds of different organizations.
Yeah,
so that would really help to, that would have an impact on the impact of your work, I suppose.
Yeah, no, that's completely true. And I guess together we've already been testing complex models on the cloud. So we've run weather forecasting models, which are very intensive in terms of data and processing requirements, and we found that the cloud can handle these, and we've only really kind of tested the water with them so far.
We just kind of scratched the surface, haven't we? Because really we've kind of like opened a window onto loads of different opportunities, and we're not exactly sure which of those are right for environmental modelling or for running the weather models and so on that we talked about. But it's a really fascinating area that could really help to open up the world of environmental modelling to further impacts and wider impacts as we learn to deal with climate change and so on.
Yeah, and I guess as well that the cloud is continually improving, and I guess it started off quite expensive. So to run these really complex models, it was quite expensive on the cloud. I mean, still, little in comparison to, say, the overall cost of a high performance computer. But I guess costs are coming down, processing's going up, so we're really kind of almost hitting this sweet spot where we might transition to more cloud computing than traditional ways of working. So
so it's a really exciting time, I think, to be working in this domain, because new things are happening and new opportunities are there.
Yeah, I completely agree. Thanks, Will.
Thank you very much.